Right, so this is part 4. We've already had a couple of people in the chat just mention about parts 1, 2 and 3. And there you go. So delivering GCSE maths, everything you need to know, the part 1, 2, 3, what they were called when they went live, and they are available to download from the PD Academy and watch from the Pearson webpage in terms of the support and the videos and all of the math support that they've got out there. So you can find those part 1, 2 and 3 via the webpage. Any problem with that, let us know. So this session, this is about teaching methods. It's not about what I didn't want to do. And when me and Mel sat down and talked about this presentation and the suite of these sessions, what we didn't want to do is just go down the route of what you could hear in any session about bar modelling, if you wanted to learn about bar modelling, or about unitary method or whatever. What we wanted to try and do is build up a bit of a suite of ideas that you can dip into, think about, but also across the different key stages, what we've picked up over the years, but also in particular what I've been picking up this year, because we're working on a 5 to 8 continuum project with our local hub, is what is down in key stage 1 and key stage 2 that can follow all the way up. So this is about building up a suite of ideas and picking out what works and when they work. And then also hints and tips for exam success in terms of those ideas that we are calling methods, but there might be just ideas, methods, strategies.
I've been thinking a lot about this lately, about methods. And it was something that very early on in my career, I didn't want to give a specific method for a topic. It was part of this feeling of I wasn't quite sure whether or not I could just go, right, this is the method for this topic. And it is very much the way I teach now, that this is the method. And again, a bit of a health warning is that because of the kind of students I teach, I might not, and I see maths as this massive decision tree. Is it a triangle? Oh, yes, no. If it's not, you go off and you follow those routes. Is it right angled, which means you do this? But then in terms of the actual methods, we're talking very much broad brush strokes in terms of trying to give those students, again, health warning, because the kind of students we teach, a method that can be deployed in lots of different topic areas. So I've been thinking this week about how much I use two-way tables, how much I use arrow diagrams, and how much I use trees, i.e. frequency trees, but more to do with getting organised. And it's quite nice when you see a student. So my year 10s have just done a test, and it was really nice to see that on 3 of the topics, when my year 10s had used my arrow diagrams, because they're getting the idea that the vast majority of understanding with GCSE maths is about proportionality, scaling up, scaling down. And so they'd used it on 3 different occasions. So this is about giving them that toolkit, really, like I've said there. Then I went back to look at what the EEF recommendations were in terms of methods. And there's so many places, and we've got some recommendations if you want to go, oh, how do you teach factorising? How do you teach this? So we've just looked at some of the themes that we use within our teaching rather than specific, I'm going to get told how to teach compound interest or simple interest, or that's not what we were aiming to do. Because you will teach, your context will be different. So that's me doing my usual health warning bit.
I suppose just knowing the contexts that we are teaching in, whether we're in the secondary upper end, so the years 10, 11, 9, 10, 11, and really utilising the fact that there are some great ideas out there lower down the year groups that really just, and like Mal said, that find it interesting at the moment, and me too. What is it that's out there that can really support those students? And I'm not talking about the fact that they've had 2 years out COVID and all of that kind of stuff, but obviously that doesn't help. But what is it that can really help give us ideas, support? And I'm not, again, not even just talking about our lower attaining students. We're talking about what could work, what's different, some ideas. And we were talking at our continuum meeting recently in terms of Numicon. So that's the top stuff. You've got the number bar, I can't remember what they're called, the bars that break up into tens.
Cuisenaire rods.
That's it. But then the one on the left that I've made a bit bigger as the image is the double-sided counters positive,
Yes.
negative counters, which really help every level of student fully understand when you are utilising and working with negatives, and what such an area of maths dealing with negatives that causes a problem all the way through their education and really comes to a head right now at this point as we're getting ready for the year 11 GCSE exams. And I'm sure that there are ways to build in before we get to this point. I'm not saying the perfection, but different ways of building in that they can see them in a different way. We've got number lines on our walls in our classrooms, but what is it that we could do a little bit different? And how many secondary teachers out there, and hypothetical question, utilize those double-sided counters? And I'll tell you what, after the conversations we've had, I say this week, it was actually last week, on purchasing some, I want to see them in action with my years 7, 8, 9, 10 and 11 students. So just think about the resources, the visual, hands-on resources that are out there that can help with the basics.
Yeah, and I think you've stood in a classroom enough times seeing me teach when we team talk for years. And I always talk about, especially when we're talking about year 11 and we're just throwing enough stuff at the wall and seeing what sticks, that you have to separate the method for, I don't know, expanding double brackets from their poor arithmetic with negatives. Just because, so I could prove a student can expand a double bracket if they're both positive, but then they need to, in their head, be able to separate the fact that they've made an arithmetic error from the new process that they just learned. And if we got it right lower down the school in year 7 and 8, we wouldn't be knee-jerking in year 11 trying to do, well, like I say, throwing that stuff at the wall. We've got to try something different. So there's some amazing stuff. It's the double-sided counters. You would hope that they could move from the concrete to the abstract. And some students move too quickly from the concrete when they're not quite ready for it. And so we both have this fundamental belief that all students can access the vast majority of maths if they were given the access to it at the right time when they're ready for it. So yeah, if we can get that right, there's some great websites out there that with resources for Cuisenaire rods, which are brilliant for introducing algebra, and especially when you're lower down, when you're talking about Key Stage 3. Interestingly enough, I've got a cupboard room in the back of my classroom just over there. I've been in there 3 times. The first time I went in there must be a 2-foot stack of Cuisenaire rods trays. Have I got them out since September? No, I haven't. But every time I think about algebra, especially, I don't teach 7 and 8, but my year 9s that I've just taken on, I think they would benefit from having something that's concrete rather than just going straight to the abstract. The EEF report that I've mentioned that we've referenced earlier on, I'm going to ask Seb to drop that link into the chat, because I just think it's important, if you haven't read it, just to look at some of the recommendations.
Throughout the research for this session, I came across this school and their document that they've got in terms of the maths methods. I just thought it was a really nice visual one. This is just a reference to have a look at in terms of their models, their ideas, what they've got visually. I thought it was a very, very good case study to bring into this presentation. Now, the conversations that we had around these algebra tiles, and it's still basics because we're following up in terms of these representations, these ideas, these concrete pictorial of what the numbers are doing. But it was when someone said at the meeting that they actually use these algebra rods for their A-level teaching and their A-level maths and their upper end, particularly expanding brackets, building that idea in, just got me really thinking that actually that if these students are fully open to the idea at primary schools, which they are, of having these different visual representations, what is it that we suddenly do when they go to secondary school and chop it and they're gone? Why are we not building it all the way through and it becomes the norm at A level that you're actually seeing these ideas, these numbers, these philosophies, whatever we're talking about, in a different manner to really help make it stick? All of these images I've just literally taken from Google from a search, and quite often they're from Amazon in terms of where they're for sale. And the algebra rods, I think, are genius. And it was when the passion of the person that was presenting this to us last week in terms of the A-level teaching and the the binomial expansion and all of that kind of stuff. It was just, actually, yeah, it makes sense. So building and thinking about what we have right down at the lower end in terms of the year groups, all the way through to when these students potentially leave off to university.
Yeah, and I think that's really important in terms of the models, whether it's bar modelling, it's got to be something that you can introduce from year 7 right through to year 13. In the ideal world, that they can become so used to using them. I know in reality, because of the kind of groups I teach, I'm reluctant to get equipment out just because behaviour. It's about being on a journey. Ask me the same question with the same groups in 3 years' time, I'll be in a different position. But because I've just joined this school, I'm at the position where I'm still asserting myself. I'm still making sure that we've got routines, and it's got to be a real trusting relationship. For me, that's my personal choice, my professional judgment. And I know some people would have a different view about, well, you've got to train them early. And I get all that. But for me, I just want to make sure that I've got behaviour nailed first before I can let them loose. It's the same with group work and turn to your partner and all that kind of stuff. Maybe I'm just a control freak.
So we've talked about the physical. Let's talk about the written, the methods that are out there. Again, starting off with the basics. And I know that the Key Stage 2 SATs and the teaching of multiplication has generally now, with the introduction of the newer SATs in recent years, it's longer multiplication. These students tend to come to year 7 and secondary school with long multiplication as the main method. And again, this continuum meeting that we're having with our local schools, they're very open and honest that it is that method they use. When the SATs are finished, or before, way before the SATs, but around the SATs, it's all very much long multiplication. But either side, they may, depending on the school they've come from, have different, I suppose, ideas in their toolbox on how to multiply, the grid method, Napier's bones, whatever it happens to be. And what we found, and again, Mal's already mentioned it, we worked together for years, taught for years. One of the things we loved doing as a new year 7 group coming in was spending time playing with numbers.
Yeah.
And a great one to start off with is just your countdown number game in year 7. Introduce it. If they've never seen it before, introduce it. If they've seen it before, off you go. And just watch what they do. Obviously, it's a nice competition that they're trying to use all the numbers to get to the magic number. Take the timer off. Don't worry about the timer. Watch what they do.
There's a great one on Enrich that uses fractions as well, which is great for your top end.
There's loads out there, isn't there?
Yeah.
Like Mal said, you can even ramp it up further down the year groups. But it was always just an interesting start to find out what they know. There was about 15 different feeder schools that we used to have in the previous school. So it was about what do they come to you knowing, but watching it happen. And what we love to do then, and particularly it is multiplication I'm talking about here, we'd spend the first couple of weeks just investigating different ideas. What's the best one for you? Long multiplication is not necessarily the one that they want to use, and the grid method is great. I know it's open to its own conversations in terms of getting the number of zeros wrong that you're putting on, all of that kind of conversation, but it also aids when you get further down in terms of algebra and expanding brackets. So these methods and opening out the toolkit for the students with the basics really does give you the opportunity to develop and have ideas. And again, Mal's already mentioned it, the arrows, whatever you do to one side, we do to the other. That direct proportion method is across a suite of maths, not just the one area that you may introduce it with, recipes or exchange rates that we'll talk about in a few moments' time. But getting the basics open and talked about, whether it's pictorially, whether it's with the bars, whether it's with the Numicon, whether it's with the double-sided counters, whatever it happens to be, and then developing it into the written method and opening out those toolkits for the students really does. They've got more to pull from. They've got a bigger frame of reference, and they find a comfort zone as well in terms of, right, yeah, I do like this method. You might find your whole class love and are brilliant at the long multiplication method that they were really pushed with, ready for the Key Stage 2 SATs. But you might find one or two that actually, here we go, they found where they really are good at the multiplication now. Right, bar models. I remember these used to scare me. The phrase bar model. I didn't know what to expect. I didn't know what it was, and people were talking about it. And I've done my methods, and I like my methods of teaching. And let's face it, it was all about ratio, wasn't it? When it first came out, the bar method. It was right. Ratio is now the bar method. Essentially, what I was always doing is the bar model, but without the physical box around them in the first place, like that we've got in that example with the number of pencils and red pencils and blue. But again, it's just something visual. It is not a process straight away. It is a process from something visual. And just having that 20, the yellow 20, matching up to the 4 5s that are blue in line with each other sends a real big message of, oh, they're equal to, without saying they're equal to. So it is all about the visual part of it.
Yeah, and you would hope that your more able students will move quickly to the abstracts, but there isn't a reason to move away from the pictorial if the pictorial works. I look back at some of my work solutions, and quite often I've drawn a picture, I've drawn a diagram, I've drawn a picture, a wavy line that represents a journey that this person's gone on. Some of it's by car, a little picture of a car, then they've done an aeroplane. And it works. They don't always have to go straight to or eventually to the abstract. The bar modelling, used to call them buckets. This person's got 5 buckets and 4 buckets. It became a way of labelling what teachers were already doing and formalising it, I suppose. What is interesting as an exercise to do that will encourage students of the importance to draw a picture, especially when it comes to ratio, is there is a classic question on Pearson somewhere that talks about milk chocolates and dark chocolates in the ratio 2:1. And then it says there are 24 milk chocolates. How many chocolates there in total? But what happens is that classic question, students go 2 + 1 is 3, 24 divided by 3, which means I've got 16 and 8, and don't realise that the number they've been given was one part of the ratio. And I've done that question, and what I did is I stuck it into Google Translate and came out with a Dutch version, or I think it was Dutch, and I gave it to the students. Every single one of them did exactly that. They followed I did it in a different language just to show them that they're not really reading the question. They're just seeing a ratio and they're seeing a number, and then they automatically assume it's a sharing in a ratio exercise question. And then I showed them what the question really was in English. And every single one of them then realised, oh, maybe I should have drawn a picture. It wouldn't have helped with the Dutch version, I know that. But on the English version, because they were adamant that they were right. And there was another classic one, I think it was in the November paper, where it was 30% of people at a show are women, 13,756 are women. How many men are there? And they had to realise that the 30%, and they didn't have to find 70% of the number that they were given. They weren't relating to the information they were given. And very much when you look at the science behind cognitive load, they're holding things in their brain that would be better off getting in paper, that they can then use that little bit of their very simplistic version. So I'm not a cognitive scientist. This is my really simple version. They then need that little bit of working memory to think about the problem. So I talk about, like I've said before, tables, arrows, trees. What can we do to get organised? But some really interesting exercises to do when it comes to ratio. Look at all the different scenarios. So the first example we would do in our teaching would be very much sharing a ratio. Very simple, 2 people. We might then, their question they do would be 3 people. That's the difference. It's a little bit of stretch from what they saw. They sort of share into 2 people. So we then go, okay, it's the same. But then the next question we would put on the board might be, this time, A, B, and C share some money. A and B in the ratio of 1, 2, and 5. A and B share £56 or whatever the number is. And again, they will instantly go 56 divided by the 3 parts of the ratio, rather than stopping and thinking about what does the 56 relate to. Oh, it's only A and B. and that kind of stuff. So rather than just the danger you've got, if you give them sharing the 2-part ratio and then you give them 27 to do, all they're doing is adding and dividing and timesing, but not thinking about the sharing bit in a ratio. And I always introduce ratio by talking about sharing not being the same as it is when you're a little kid and parents say share nicely when they mean share equally. Ratio is all about it being fair. So if I do 5 hours work and Sega does 1 hour's work, I should get paid 5 times as much as Sega. No sort of sarcastic comment, Sega. So the idea being that you have that variation of questions and it's not more of the same, because all they are doing, it's same with fractions of an amount. All they're literally doing is dividing and timesing. So I might do fractions of an amount, get them to do 2 or 3, but then the next one, I would very quickly move on to where they're given what a fraction of an amount is, and they have to work out what the amount was, so working it backwards. Massive part of the planning for teaching comes from thinking about the progression of questions I'm going to use. Well, that is for me is, okay, I'm going to do that, they're going to do that, the next question is going to be that, they're going to do that, and a progression through a topic rather than just more of the same.
The bar model really comes into its own, I think, as much as it's a great method for, like Mel's just talked through the ratio part, but can really come into its own for reverse percentages.
Yeah.
Once they've got that basic understanding, and you've mentioned that kind of image before, and then you start doing, and Mel's already mentioned about fraction of an amount, but working back to what the actual part was, or the whole part was, it becomes kind of second nature to use them in both ways as a reverse process. And again, thinking about reverse mean, if you're given the mean, you can use the bar model to create and work back to the total, etc. But there's so many different ways to use it, but it is pretty much just a formalization name to what many maths teachers have used before, but then thinking about keeping it as almost a standard in your language, in your way with the students. It might be bars, it might be blocks, it might be sausages, it might be whatever you do that works for your teaching style, but trying to keep it across a range of topics, actually then the students see the links between them all. The language, part, whole, it's very much primary language. The students will come to you from primary into secondary. They know that language, part, whole, and it is just a matter of them putting it into, and I'm sure they've seen it before at primary school anyway, that visual representation. But like we've mentioned 2 or 3 times now, being taken to different levels of maths now.
What you've just mentioned there, Siga, the fact that when you introduce another topic with a familiar tool that you're using, whether it's a table, whether it's a diagram, whether it's a bar model, it allows them to form those links in terms of the links across the content. So using the bar models for reverse percentages, it takes away the fear of, oh my God, this is a new topic, it's too hard. And all of a sudden there is a thing about it that they look at and they go, actually, I've seen this before. So it's just giving them another tool to use, really. And then we use portion tables. I call them arrow diagrams. And actually, more and more, I'm using the language scaling up, scaling down. So sometimes we can go straight to scale up. Sometimes we need to scale down to scale up. And it was really interesting this week with one of my year 11s. The one arrow diagram there on the left, there was a direct proportion question where he had done the horizontal arrows, whereas my arrows will always be vertical. And he went, well, they work both ways. And he'd worked that out for himself, but I hadn't explored that with the particular group. So kids can figure stuff out pretty quickly for themselves. It doesn't have to be drawn in a table. Mine rarely are in a table with boxes because kids, oh, do I have to draw a table? No, you just have to write. And I think with one of the things we're going to talk about in a minute, one of the things that I have learned in the latter years is that when it comes to things like 5 pounds of apples, I will include units. So where I'm doing my first equality statement, so £5 of apples equals $15. I make sure that I'm using the words pounds of apples and using the dollar symbols, because otherwise it just becomes very, students forget what it is. What does the 5 relate to? What does the 50? Oh, it's money, it's pounds, it's weight. So actually include the measures, the units.
Once they get used to this method, and not a quick fix at this point in year 11 now, but over the course of your period of time, and Mal mentioned about the fact that if you fast forward 3 years, where will your current year 7, 8s, 9s be in terms of the utilising of you, assuming they've stayed with you as a teacher, where will they be with these methods that you're talking about and embedding with them? It comes to fruition when you start marking their mocks in year 11 and you're working through and you see that they're remembering. I'm not saying perfection in terms of getting the question right, in terms of a toolkit to pull out and go, right, I'm going to use that with this question. The amount of direct proportion ripples through, and I don't mean direct proportion in terms of a question that says A is directly proportional to B. I just mean all the different maths that is direct proportion is ridiculous. It's a huge amount of topics in terms of examinable questions. We can reel them off now. We've got exchange rates, recipes, best buys, ratio. There's a huge amount where this, okay, proportional tables, arrow tables, scaling up diagrams, scaling down diagrams, whatever you want to call them, it's basically organisation. That's what it is. It's organising in a visual way that the students are seeing that actually there is a relationship between these numbers. And spotting that there's a relationship between the numbers is half of the battle. These are from the November papers just gone, just 2 on the first paper I opened. You've got a recipe there. There you go,
Yeah.
direct proportion. I had my students writing 20 cookies in one side, peanut butter 250, 20 goes to 60 by times in by 3, 250 times by 3, 750, got 150 left over, job done. And
Yeah.
nice, simple organisation.
I've mentioned this earlier, and this really demonstrates the point about not teaching them a method for every topic. Some teachers, rightly or wrongly, and again it's about context, would say, oh, but when it's recipes, I get them to scale it down to 1 and then scale it up to 60. But that's saying to a student that for this topic, you do that method. Whereas we're saying that actually you're scaling up, scaling down, it's all direct proportion. And in their minds, it's one method for lots of topics.
Yeah.
And it seems to work for that specific group of students that we teach. Yes, for your set 1, you can, because they've got a better recall. Teach them, and that's how we know all of these methods. We know constant proportionality because we've remembered it from being students ourselves. And the second one is exactly the same. It's direct proportion.
This question here was in the majority, even my students that I've been teaching and talking about direct proportion idea, the table, still went down the route of, right, 100 grams divided by 5 grams is 20. 20 is how many bands I've got. So, and they went down a route of division and looking at the numbers, trying to add, take away, divide, whatever it happened to be. A few, and one in particular that really surprised me, a little table of wool, so grams and pounds, little column, 100 next to 3, then went down to 10 next to 30p, then went down to 5 next to 15p, 15p plus 8p, there you go, 23p. Job done.
Yeah.
And honestly, I put his, and it was really annoying because I put his paper to one side to take a photo of it. He'd seen it on the side, took it to a different side, one that I didn't get a chance to make a photo of for this presentation, but I did get a couple of other people's in terms of organisation. You can see there, that first one, you can see 100 grams arrow, £3, down to 1 gram, 0.03, times it back up, scaling down, scaling up. The one who did it in 3 lines of writing, very similar to that method, but got to the 15p plus 8p, job done. Whereas this lad went on to a different route, even though he'd actually done everything to perfection there. But it's all about showing methods, building them in. And what I was pleased with is the amount that were trialing it, even though they went on different routes, of getting organised. Like I've shown there, that first one, 100 grams, £3. went up, went down to go back up. Didn't need to, obviously, could have just gone down by divine, but it doesn't matter. Exactly the point Mal just made. You're not trying to enforce it. You're just saying this is a method of bouncing up, bouncing down, up we go, down we go. It's about doing that. It is, and it really does reinforce as well that the fact that direct proportion and these topics, all of these topics, multiplication, division, it gets that silly idea of just adding on, taking away, because they're always seeing that same process throughout all of the maths.
Yeah, and they also don't see it as, oh, for that topic, I do this method. For that topic, I do this method. Because that's part of the reason that students find maths difficult, is that they just see that there's every topic has its own method. Well, there is things you can do that cover multiple topics.
I popped these in as a slide, just as a reference to have a look at. Again, I've learnt these relatively recently. They're called the checkpoints from the NCETM, and loads of areas. In fact, I think it covers everything, but in terms of what they are and interactivity, they're different for each maths area. We were looking at a brilliant one within the group of place value. The place value ones are brilliant, and getting to really think about how to chop a number line up. And there is presentations, and you can put those up. But I'd highly recommend having a good nose at those. So think about number lines.
Yes, number lines for times. Again, specifically when you get to year 11, they seem to think that it's babyish to draw number lines. And yet I will draw a number line for time. I will draw a picture of a wavy rose and a little panda car showing the journey, just so they can understand what the story is. And that just comes from Seeger from years we're teaching him, where he goes, what's the story? Think about the story. But number lines, and then you will have a discussion, or you make your own mind up as to whether or not you go for vertical number lines or do you go for horizontal number lines, because there's train of thought that says we should be using vertical. So yeah, they're interested in making sure that you say to year 11, it's okay to use number lines. It's not babyish. In fact, open your paper. If there's a blank piece of paper, draw yourself a number line, 1 to 10 and 0 to -10. I love a two-way table. And this is our first ever lesson that I do with any group, regardless, a little bit maverick, regardless of what the scheme of work says. I will spend some time doing two-way tables, because it's not about a two-way table. It's about organising the information, extracting the information from a question. It's giving them a strategy to use, whatever the topic is. But we use them for compound measures, those questions where the two-way table gets broken for certain rows, and I'd say to them, look, this is hard because for density we don't continue adding. That's a compound measure, and you talk about, so that row we've got to calculate it. Reverse means just getting organized, and it seems to help with students extracting information from exam questions. Absolutely love them. And then frequency trees. I wasn't a great fan because I think it's made up maths, but again, it's a way of organising information. So I might lay this out as like a prime factor tree going down rather than a horizontal tree. So I might do it vertically. So where you've got 165 at the top, and then I haven't got to keep reading that, because our biggest challenge as well in the secondaries, is we're all hearing more and more, is literacy. So when they're faced with that question and a blank sheet of paper underneath, they tend to switch off. So I'm saying, look, we need to reduce the cognitive load. Let's get 165 in the top of your page. Then it's either black or white. So underneath, black and white. We haven't got to read that sentence anymore. And then start dissecting the rest of the question. And then all of a sudden, the routes through the question start opening up once you haven't got to keep going back to that and reading all the words. But yeah, so our two-way tables, arrow diagrams and trees throughout, they become my written themes that I use throughout.
And what you'll find is it's adding a method to their toolkit. They're less likely, the students, to leave things blank. They're less likely to give up on a big, juicy, wordy question because of the amount of text or numbers or stats or data or whatever. They're more likely to go because you've exposed them to several questions across a range of a suite of things with these styles, whether it's a bar model, whether it's a two-way table, and they're going to give it a go. It opens up that perseverance, not just giving them maths knowledge.
Yeah, so I spent some time, and you may find it useful for year 11, but also as a resource for revision sessions. I've pulled together from past questions where we've used two-way tables, arrow diagrams, trees. And then I've done some work solutions and annotated it. So things like that we would see with each other's teaching as standard operating procedures, but also that we would be explicitly telling the students about, now, do you notice I have written the units down. So you can see there, on the right-hand side there, the banana and yogurt question. Each time I've written the units down on every line. I know that in practice we can save some time, but I'm now a massive convert of talking through students why I'm doing every single step and being blatant about it, to the point where things like, and I think I've mentioned this before, that when it comes to writing a unrounded answer, I didn't realise I do it, but when I'm writing 12.7465 ... I then follow it with blah, blah, blah. But my students, 2 of them in their mock, had written that at the end of their unrounded answer, had written the words blah, blah, blah. It's not going to get them any extra marks, it's not going to penalise them, but it's to the point where it's obviously sinking in. So I pulled together, there's 45 questions, I believe. I've tried to get unique topics. So it goes from equivalent fractions. We use arrow diagrams. Whatever we do to the right, we do to the left. And they're already familiar with that concept. So why not just show them that concept of whatever we're doing here, we do here, across a range of topics. Then there's the way it's laid out in terms of it looks like a tree, or it's a two-way table. And I have annotated them in some random colour that you might find useful. And I'd be really interested if you go, actually, I would use the unitary method for this, or you could use the unitary method for all of these topics. And yes, for a lot of the topics, I am going to address this because I thought about it as I was driving in this morning. The unitary method does rely on having a really good grasp of division and being able to divide by some tricky numbers sometimes, which is why we move away from it. Again, context. If it was a different group of students, I might insist on or might use it more. Would you agree with that, Siga?
Yeah, absolutely.
Yeah, so we tend to scale down to numbers that they're comfortable with. So I just thought that was useful. I'm going to use it for my revision session after school tomorrow. So it's served up 2 purposes. And there is a little bit of inverse proportion in there for a bit of a challenge, because we will teach inverse proportion as part of introducing direct proportion. And we're talking about whatever, this one goes up, this one goes up. So that's direct proportion. And we introduce the idea of inverse, that one goes up, the other goes down. And again, it's allowing students to access some quite tricky topics then when you're giving them a method. And Seb will make that available. It will be up on the Emporium at some point as well.
A few hints and tips and ideas that just, I suppose, more anecdotally along the way. When we, particularly the wordy questions, particularly those questions where there's a direct comparison or a conversation happening with those bigger questions about 2 different people. Amir is driving from Sheffield to London. Sharon is also driving from Sheffield to London. We've got 2 people. Let's split the page. Let's get organised. The November papers in regards to the hourly wage in the UK is this. In Australia, it's this. She thinks that it's more in Australia. Right, let's split the page. And every single one of my students for that question split the page and had UK and Australia. And then they had all the information nice and organised. Every year, without fail, the chief examiner puts in the notes about clarity, understanding, not just handwriting and neatness, but organisation around the page and the answers from the students to enable the markers to see the marks and give the marks. So this is a perfect way of doing it. So the student straight away, the first thing I say when we get to one of these questions, what do we do? And they say split the page. It is about organisation. If we've got three things, let's split it three ways.
Again, in terms of that splitting the page, it's across topics. It's not for this topic, this is the method. It is multiple methods that we will talk about that as a strategy, isn't it? Best by, speed, distance, time, wherever it's applicable. It goes back to that toolkit. We're saying here's a strategy that you can use to get organised, and once you allow them to get organised, they can start seeing routes through the question that may not have been obvious when it's just a bank of text.
And I think that's the hard bit here, is getting through that bank of text. And if you've got some strategies and processes in place, it enables you to do it. So then you break down the question, whether you use highlighters or not, whether that's something you promote in school. The use of highlighters is fine, but you have to, it's not just something to make it pretty. It's not just the number sometimes. It's about finding what's key. If you was to stop at a certain point, have you hit something that is make or break? If it's make or break, you highlight it up. You draw a diagram, your bar model, your frequency tree, your two-way table, your unitary, whatever it happens to be. You break down that question and find what you can use. And when it comes to that answer at the end, you write down everything. And particularly when it's on the calculator paper, what I mean, that you write down everything. You cover your back. You've seen it, you write it down. You've typed it in the calculator, you write it down. The amount of students that assume a calculation, but not knowing it's worth a mark. So I was thinking about a question I went through yesterday when we was reviewing the mocks. It was a mean, working out a mean question. By default, they add them up and they write down the total. If they write down the total that's wrong by mistake, they're clearly not going to get a mark. But if they're showing that they're getting the total from the correct numbers by writing down that addition that they would have put in their calculator, they're on their way to picking up the mark. So it's all about getting used to writing down absolutely everything. And we hound that from the second we start teaching them. You write down everything that's in that brain that's relevant to that question, or write down everything you type into that calculator.
I know all that sounds easier said than done, though, doesn't it?
It does.
When you're
time, doesn't it? This is drilling over time.
Yeah.
I've put this in here. We mentioned this at the previous in terms of resources session, but it is a method. It's a method to help them remember tunes, songs, video, visual. A couple of videos at the top there are just great videos that are used year after year. So the top one, Johnny Ball, number of black cabs in London using the capture recapture method, great for your higher tier students to see it in play. You've got your powers of 10 just to talk about sheer size of numbers to introduce standard form. But then this one here, the circumference and area of a circle song, that version of it, you do get a few, Google it, that one that's got that little background there. So it looks like it's on a bit of a farm, or it's got different circles in the background, has a very annoying tune, but my year nines can reel off the circumference and area of the formula straight away. Admittedly, they hate me for that song, but they know it straight away. And likewise with the area of a trapezium for the Pop Goes the Weasel tune, great way of drilling it in. It is a method. It's a resource, but it's a method. It's a method of teaching, helping them retain key formula, key facts, key knowledge, introducing things. The power of video does go a long way. Just don't overdo it. Don't be all right with, we're going to watch another little video in maths. When they do come along, they've got to be good ones. So that circumference song there, brilliant. It's genius. It's annoying, but it's genius. Whiz through these, Mal, conscious of time?
Yeah, really conscious of time. So trying to get parents to understand the power of maths, and they have a massive impact. So we try to engage, so it should be really engaging with students and parents at whatever opportunity as early as possible with maths facts, maths calendars. There's loads out there now, and do whatever we can to try to create that positive vibe, because I think that's important, more so now than ever.
I think it goes a long way as well, doesn't it? It's not just giving them the idea of what's going on in the classroom. It's bridging that gap between school and home. It's making a relationship stronger. When the parents talk fondly of the communication that they get from that maths teacher with their parents, students at home, it sends a better, more positive student into school the next day. So it works in so many ways. And I don't do it enough, actually. I do it a lot with year 11, and Mal probably agree. We do it a lot with year 11, but not so much the rest of the year groups. And I think there's also a strategy in that the fact that we want the communication not to get lost over the years, and we want it to be really focused for that year 11. But when you do have that communication, that ongoing communication, and sharing with them what you want them to do, ideas, we send home the rag papers for the mocks every month, the maths calendar. It's sharing the maths that's being done. How many parents at parents' evening go, oh, maths has changed since I've been there? Well, let them have a look at what it's like. It hasn't really changed. There's a couple of different things in there, but it hasn't changed. So it's just a matter of building up, and it's a relationship. It's a method for building up that relationship to hopefully have more work being done at home to support what you're delivering in school.
I think also that engaging with parents and knowing how tough it is sometimes in terms of behaviour when you take on a new class. I use it I always send all my classes hi, this is me. Just to let you know I'm their new maths teacher. So here's my email in case there's any issues. I'm here to help. And then very quickly, as soon as there is an issue, I'm on the phone, because they need to realise that teachers don't come to work to do a bad job. We don't get up in the morning and go, I'm going to be really rubbish today. I want to come in and know I've done a good job. So that engaging with parents from very early on. Another way that we use in terms of across our teaching is we call them the bread and butter. So worksheets that constantly revisit. There's loads out there. But what I'd say is make sure it follows a scheme of work. I'm never, ever going to ask you to do anything I don't think you're capable of. That doesn't mean it's going to be easy. I'm never going to ask you to do anything I've not taught you. So I make sure that mine follow our scheme of work so that they would never get faced with something. Because I remember as a student sitting there where the teacher would go, oh, don't do question 6 or question 8. And I'd sit there thinking, either I'm stupid that you think we're not good enough to do that, or you're rubbish because you haven't taught it. And I don't want the kids to feel that. I want them to feel this. We've got to get them on this upward spiral of success, confidence. And that only comes from carefully planning what you put in front of them, not just anything that they may not have taught. And then you will end up spending loads of time on it because you're having to cover stuff that they haven't been taught. Whereas because everything on there we've taught them, literally 10 minutes, right, let's move on to the main part of the lesson. So it is proper space retrieval.
And it's your opportunity to constantly say, methods, what are the methods here? What can we do here? Oh, here we go. It's a direct proportion question in disguise. Oh, we've got a two-way table. We can draw our table. It's a constant reference back to the methods that you're drilling in over those years. We've got the one-marker starters, which are on the Emporium. It's a collection of all the one-mark questions on the foundation papers over all the sittings up until November. So they do need to be updated a little bit with a couple of sittings on there, but there's still 16 starters. Again, reiterating all of the basic key skills that you've hopefully been drilling in all the way through 7, 8, 9, 10, and whenever you decide to use these one markers. And then just a worksheet doesn't have to look like a worksheet. Spice things up. When they're sitting at a GCSE exam, the questions are going to be in a random order. We don't know what to expect. We don't know what they're going to be like. We constantly teach a topic in maths. We practice it. We move on. We do an assessment. Lots of schools do end of topic assessments, so it's all very, very relevant to what they've just done. Think about spicing things up constantly over the course of the course, the key stage, the school, where these questions are jumbled up, mixed, and you can constantly reiterate, oh, this is our method for this. This is our method for that. So it's building in repetition, but it's also the realistic approach that they're going to be jumbled up, but it looks different. It looks nicer. It's not just a normal worksheet. It's got a bit of elements of either competition or you're spinning around the page where it says start. The amount of students will buy into that instantly compared to just the run-of-the-mill list of questions is huge.
And if you print it on A3, even better.
We've got no money in our place, so we can't do that. No, definitely not colour either.
Colour and A3. That'd be amazing.
There's loads of if anyone wants a copy of that, I will happily pop one in the post to you. And the reason for that is because we tried to keep very consistent methods running through the key crossover topics. And like I said, drop me an email, pop one in the post, not a problem. Further reading.
If you're looking for specific methods that you want to hang your hat on, definitely worth looking at Joe's book. And then Pete's book is very good, and he's got a second one out now, not about representations, but very, very useful for further reading and going into more detail, because we did only have an hour. Absolutely. And there is only so much you can do in an hour.
Don't forget the upcoming Getting Ready to Teach for the new extended maths certificate. Very exciting. Can really challenge some of your students on in your school there. So get signed up to that. 13th and the 25th of June. And the final part to this suite, part 5, final exam hints and tips, which is on the 24th of April. Book onto that one.